All right, welcome back. We're continuing our way through finding surface area and volume for 3D shapes. We've already talked about the prism, the cylinder, and the pyramid. Today, we're going to talk about the cones, which can be related to cylinders. Just like a pyramid can be related to a prism, a cone can be related to a cylinder. So if you want to join me, we're going to be on page 126, 127, outlining it just like we have the others. So we're going to start with surface area. And volume. This will be the title of both pages. And these are pure or cones. Sorry. All right. So let's look at on page 126. Let's kind of look at cones and the things that we could have. Now, there's a couple ways you can draw cones. Kind of draw it straight up and down here. Dot it in the back there. So we could have a cone that looks like that, or sometimes we draw them like this here. Okay. Now, though cones are related to the cylinder, like the pyramids were related to the cylinder or to the prism, cones and pyramids can be related in their equation too. If you remember how we related the cylinder to the prisms and their equations, we could actually use the same equations for them. We can do the same thing with cones. Okay. And we still have bases. Okay, so this circle here is still our base. With the other items, we had, we needed the radius. So you may have the radius R, the radius, which is half the diameter. Sometimes they give you the whole width down there. We still have the slant height, which is L, which is this length of this side right here. And then we also can be given the height, which, remember, the height and the base are perpendicular. So this is H, and then this over here, perpendicular, might be H as well. If we want to look at the surface area, I like to draw the net for the surface area. So we have our base, which is a circle. So you need to find the area of a circle. And then you kind of have this funny looking shape that may look something like this. Sort of a pie piece. It's actually called a sector. Okay, and you would have to find the area of this sector. Now we have formulas here. Okay, so surface area, and all the cones will look like this. They're just going to be different sizes. So for surface area, you can start with the area of this circle, which is pi r squared. And if we look back here at surface area of a pyramid, we started with area of the base. Now the base will always be a circle, so that's why we leave it pi r squared. Okay. Now, here we have the slant height, which we still have, but instead of half the perimeter, okay, we have to find this thing over here. Okay. Now, actually, we can go back and we can say that we have 1/2. Okay. The perimeter of this thing is actually the circumference of the circle, which is 2 pi r. And then we have to multiply it by the slant height, which was L, which we have right here. So L. But if you see here, 1/2 of 2 is always 1. So we don't necessarily need to write that every single time. Okay, so there's your surface area. Again, these are important to know and to have. Okay, and for volume, we're still going to use this. We're still going to use this 1/3 area of the base times height. So we have 1/3 area of the base, which was pi r squared times the height. Okay, so here in this picture, we have the radius, and this length right here is L, the slant height. And this right here was that part of the circumference. Okay, so these are the two formulas we need. Now we're going to jump over to page 127 and look at 3 examples. So we'll split our page into thirds. We'll get some shapes drawn here. Okay. We're going to look at surface area and volume. All right. So for the surface area, remember, and I kind of wrote a post-it again, these are the formulas. Okay, so they actually give me this whole distance across here. I only want 1/2 of that, which is 12 for the radius. So we have pi r, which is 12 squared plus pi RL. So pi 12 times our slant height, which would be this length right here, which I don't have. Okay, but like always, we've created a right triangle, and I need to find this length of the side right here. So I'm going to take 12 squared plus 10 squared equals x squared. So 12 squared is 144 plus 10 squared is 100. X squared, 100 plus 144 is 244. And then take the square root of that. And I don't believe that that is a perfect square root. It is not, so we're going to leave it as the square root of 244. So the square root of 244. We could simplify it if we wanted to, but we're not going to. Okay, so then you can see it was that number right there. So then I'm just going to put the whole thing in the calculator. So pi 12 squared plus pi times 12 times the square root of 244. And we will get about 1041.27. And it looks like we had feet, so feet squared. Now I forgot to, sometimes they want you to leave it in terms of pi. So you'd have 144 pi there. plus, if I did this one, 12 times the square root of 244. That's 187.45 pi. And then you could add those two together. So 144 plus 187.45. So you'd have 331.45 pi. I kind of ran out of room there. But you just treat pi if it were a variable like X or Y or something like that. Oh, okay, volume. Let's see, I think I did volume in blue. So volume is going to be 1/3 pi r L, or pi r squared times the height, which is 10. Okay, again, it's this formula right here. 1/3 pi r squared h. Okay, so if I leave it in terms of pi, I just multiply my numbers together. So 1/3 times 12 squared times 10. That's 480 pi, which is about, so take that times pi, 1507.96 feet cubed. Feet cubed. Now that one was pretty easy because they gave me some of the numbers I needed. It could get a little bit harder. So let's move to the next example here. As long as you know the Pythagorean theorem, it's not going to get much harder. Okay, we could do angles and give you angles and all that kind of stuff, but we likely won't bring back any of that trig. And then they give you, this is 3. That's a 3 down there. So surface area and volume. Okay, for our surface area, we're going to take pi, that's the area of the base. So pi r squared, so 3 squared, plus pi times the radius, which is 3, times the slant height. Now I know already that this height is 5. That matches that height. And I need to find this height, which is L. Okay. Again, we're going to use the Pythagorean theorem similar to before. Okay, so we got 3 squared plus 5 squared equals L squared. So 3 squared is 9, 5 squared is 25 equals L squared. So 9 plus 25 is 34. And then you take the square root of that. 34 doesn't have a perfect square root, so we'll leave it the square root of 34. Okay, so this is 9 pi plus 3 radical 34 is 17.49 pi. Which if you add those two together, you get 26.49 pi, which is about 80, I'll write it down here, 83.22 units squared. Okay, we didn't have the units on that one. And then for volume, it's 1/3 pi, 1/3 area of the base, so pi 3 squared times your height. okay, which is 5. So just multiply your numbers together. So that's 1/3 times 9 times 5. So that's 15 pi, which is about 47.12 units cubed. Okay, now the 1/3 comes in because these circles get smaller and smaller and smaller as we fill it up. All right, our last example here for the cone. Yeah, we got that. I'm gonna give you that the slant height is 10 meters and the distance across right here is 10 meters. So surface area, volume. Okay, for the surface area, okay, we're gonna take pi r. Okay, the radius is right here and it's half of this, so it's 5. So 5 squared plus pi r, which not 3, it's 5, times the slant height, which is 10. Okay, so you got 5 squared is 25, so 25 pi. 5 times 10 is 50 pi. So this is 75 pi, which is about 75 pi is about 235.62 meters squared. Okay, so if they want a pi answer, leave this. If they don't, put this in. Now for the volume, we have 1/3 pi r, which is 5, times the height. Now I don't actually have the height, but I have that the hypotenuse is 10 and a side is 5. So we have 5 squared plus h squared equals 10 squared. So 5 squared is 25 plus h squared equals 100. Subtract 25, so h squared is 75. Square root of that. Square root of 75 doesn't have a perfect number, so we'll leave 75 square root in there. So we're going to take 1/3 times 5 times the square root of 75. And that's going to give us 14.43 pi, which is about 45.33 meters cubed. Okay. Now, just like before, these are all about using the formula and trying to figure out the sides or the length in that shape. Okay, so make sure that you have and know the formulas for these. If you have any questions about this, feel free to reach out. I'll put some practice below this video so that you can work through those. If you got questions, let me know and I'll see you in the next lesson.